So, welcome to this lecture. Will be a bit different before, so we are actually going to learn how to do user interfaces in Python. And we are going to use something called a user interface library called Qt. And we are going to use Python binding for that library called PyQt5. So, just before we go through actual programming details, I just want to mention how user interfaces are done on different platforms. So the main platforms we have here, desktop workstation platform. I'm not talking iPads today, but it's similar. We have Linux, we have Windows, and we have Mac OS. And if you want to write a user interface application in any of these platforms, you need to use the libraries that are available to that operating system. So for Linux, there is a base layer user interface library called X11 that was actually developed in the 70s at Xerox. It's a client server model, basically that you have a server running on your machine that connects to client on your own machine that presents the user interface. On Windows, we have something called Win32 or WinRT. Win32 is an old programming API, was developed in the first versions of Windows. It has since been developed for 32-bit, 64-bit Windows as well. It's called Win32 even if it's also 64-bit programming. There's also a new Windows library called WinRT, which can be used on Windows 8 and above. And on Mac, you have something called UIKit and NSKit, which also are libraries for developing user interface for those platforms. The problems with this is that basically you have to, if you want to write an application, your application for each platform, you have to implement the user interface in every library for every platform. So in a sense, you have your final code, for example, that is the same on all platforms, but the user interface code has to be specific for each platform, which is kind of cumbersome and hard. So what you can do instead is that you can use a middle user interface library that encapsulates these things. And Qt is one of those. So Qt is a library that you use instead of directly connecting to X11, Win32, or UIKit, you program against Qt, and Qt knows how to work with the different platforms. So you don't have to care about Mac, Windows, or Linux. You just code your user interface. And so as I said, Qt is a C++ library. If you want to use Python, we have to use something called a binding. And a binding is a special Python module that connects to the C++ library and provides the library the same classes as in C++ for Python instead. And one of the more common ones is the PyQt5 binding that binds to the Qt5 version of the library. Then you only have to write one single Python application. You write that using the Qt classes to implement the user interface. Much more efficient than implementing one application for each library. So Qt is a platform-independent user interface library, and it abstracts all the user interface concepts in a single library. So you never have to call any of the native functions on any platform. You can, but you shouldn't, because as soon as you connect to one of the native libraries, you kind of connect to that platform, you are bound to that operating system. Another nice thing with Qt is that the user interface you create adapt to the user interface, or the operating system user interface metaphor. So if you're running a Qt application on Windows, it looks like a Windows application. Running it on Mac, it looks like a Mac application. And on Linux, it can look like many different Linux application user interface because there are so many desktop operating systems in Linux. You can also style your user interfaces. You can define style sheets that make your application very unique. For example, if you run Spotify, it's a black application styled in a certain way. That you can do with Qt as well. it also has a notion of signals and slots. That means that if you have a button, for example, it can send a signal. And you can connect that signal to slots either in code or directly to another user interface object. And when you press the button, the signal is sent. And as we will see later on in this lecture, you can respond in code when a signal is called. As I said before, Qt is a C++ library. To use it in Python requires a binding. And the binding consists of several binary Python modules. So basically, those are, in Windows, it's called dynamic link libraries. In Linux, it's called share libraries. But they are binary code that you can load just like a normal module in Python. And there are, unfortunately, several bindings for Qt. So there is the PyQt5, there is the PyQt4, there is Qt for Python, and there is Python Qt. You will see that this come up many times in open source software that not everybody is happy with a single solution, so they develop their own. So now we have three. The nice thing with this is that the names of the classes are basically the same, the methods are the same, so it's just the import statement that can vary between different bindings. We use PyQt5 in this course. So next, we'll talk about user interface programming is the notion of, it's a bit different programming model than you have been used to. So when you run your code now, it goes from starting the code to the end of the code. There's if statements and stuff, but there's a flow going from A to B. When we program user interface, the code is, there is no A to B. It starts the application, it waits for you to respond. And when you click things, code will be executed. And that's called event-based programming. And it's centered around an event loop. So basically your application starts, it goes into a loop and listens to events. So when we click in the window, there is a message sent from Windows, for example, to Qt, to your application. Depending, for example, for keyboard and mouse system messages. And it's up to you to connect these events to your own code. And the loop exits when the last window has been closed. The loop is, you exit the loop. So in pseudocode, it can look something like this. You have a flag here called running. And when the flag is true, it goes into this while loop here. The first thing it does, is there any events available for us? Yes, there is an event. If the event type is button click, and I do handle button click. So then I send away the event to a special method that handles this certain event. And then you can have lots of if statements here, or case statements, or select, switch, whatever, in this part here to check for different events. And then you also perhaps have an app quit event, for example. It's that Qt sends when it doesn't want to run anymore. And then you set the flag running it is false. So next time it goes up here, it's okay, it's not running anymore. We go out of this loop. It's on a very high level. This is not the actual event loop. It's just an example code, how it can be implemented. So Qt main program looks something like this. You import Qt widgets. By Qt and Qt widgets, we import star. So we import all the classes from this module. We use the main program concept I illustrated before. The first thing we have to do is create something called an application object. An application object is responsible for handling the loop, application loop, the interaction with the system, dispatching messages, and so on. So that is the first thing we do. We pass along sys.argv is the command line arguments, which you can use or not use. We pass them along because there are some switches you can use when starting Qt applications. So now we have an application. We need to also create some windows. So in this case here, the Q widget is the base class of all widgets. And if you don't have any other widget, it will create a window for that widget. And we create show here, and then we go app execute. This is the actual application loop here. So execute here, goes into that loop, and it will stay there until the last window has exited. And then we call sysexit here to return the error status from this one. You can also skip this part here and only do this. That's also okay. And I'll illustrate how this looks in code. So this is our application here. I have a loop here. I create a widget and we run this code here. Now you see here, without writing too much code, we have a window on the screen, which we can move. We can resize it, and we can close it. So all that functionality is built into the widget, and all the events that need are for moving the window is handled automatically for us. So we don't have to do anything more to just do this. As I said before, QWidget is the base class of all user interface objects in Qt. So this object is similar to the base object in Python, but it has all the mechanisms needed to handle widget interaction, pressing, clicking, rendering, and so on. Widget can also contain other user interface objects. You can create, if you create a widget without a parent, it will create a window for you automatically for that. You can also derive a custom application window from QWidget. So you can, that is the recommendation also, that you create your own base window, which you specialize with your own settings. So here we have a main window class. So I created my window here. I derived the functionality here from the QWidget object. I have a constructor here. And the first thing I do, as I said in the object-oriented part, we need to call the constructor of the overlying object. So we call super, which actually refers to the widget object, and we call init on the widget object. We have to do this. That makes the widget appear and sets up the basic functionality of the widget. Then usually I create separate routines for defining my user interface. So in this case, I do self-init GUI. This will call this routine here to set up the user interface. In this case, we just do set 300 by 300, 600 by 600. So this is the XY position of the window, and this is the width and height of the window. And then we can do set window title, my window. And then we have to finally show the window as well, using the self.show. So all these methods are from the QWidget object or class. So in this case here, I have some more code, and we run. Now you can see here some differences. We have my window here is the title. It also appeared at something like 300 by 300 size, and I can set. Let's see here, we do 800 by 800. Now it's a bit larger. So in this way, you can specialize the window so that you have your application has its own window and all its own attributes. And then we also have to. Sorry, I wasn't really. So to actually run this application here, we do the same thing here, create the application object, but instead of creating a widget, we create our window here using our own window class. So my window here, instantiated. In this case, we have in our init window also show. So we don't have to call show explicitly here. And then we enter the event. But the user interface is kind of pointless without being able to interact with it. So the first thing we have to do is add some controls to the user interface. And in this example here, we will add a button here. So we call self button equals to push button. The reason I put self here is because we need to have a reference to this button. If we want to interact with it in some other code in our user interface, we need to be able to get back to it. It's perfectly okay to create a button here without the self. It will be added to the user interface, but you can never reference it again because it's only available in this init group. By attaching it to the self here, we have it available for all the methods in the class, and we can interact with it. So the first one is the title of the button here. Self here is the parent of the button. So we attach the button to our widget, basically stick it to the window. So the window will own this button. We set the tooltip. That is a small box that comes up with, if you hover over the window, over the button, it will show, I have a button, please press me. And then you have resize here, you can set the size, and you can move it around and place it on the user in the window. With some XY coordinates. So you have a button here, I set the geometry, same main function here. Now we can see there. You can see there is a small button. It's you can see here that if I hover over it, it produces a small hint box. It also has all the functionality for illustrating that you're over the mouse. You don't have to program that. That is built in. You can even press it, but nothing happens here. So now we need to be able to connect the click of this button to some of our own code. So there are some different signals that you can use. So the button has several actually signals you can use. The most used one is the click signal. And that is called when the button is clicked. Basically, you click down on the mouse and you release your mouse. Then the signal click is sent. There's also a signal called pressed, which can be sent when the button is held down. It's not always useful. A list box, for example, which we're going through, could have a signal called current row change. So if you click in the list box, this signal will be changed. And to be able to connect your code with a signal, every object that you create in the user interface has several attributes connected to. So in this case, the button here has a clicked attribute, which is the signal. And then you have a method called connect. And then you connect this signal to your own code. It's actually very, very simple. And here are some links to documentation for. So there is a lot of objects in the Qt library. And I can't go through every attribute in these objects. And if you look at these links here, you can see every class, all the methods available to each class, and all this, also the signals. So in this case here, I have my button here. I created my button here. Now I want to connect this button to my own method in my class. So I do self.button. Then I have to select which signal I want to respond to. So clicked here, and then I do connect this signal to self, which is to this object here, and the method of on button clicked. So if we go down a bit here, you can see I've added a method to my class here called on button clicked self. And then I just do print hello here. So this here now, if we use clicks on the button, it will call this method. So hopefully we see how this works. If I press me here, you can see down below it says hello here. So this is basically the foundation of how to design a user interface, that you create your objects, you connect the signals to your own code and respond to that. So it's a bit different way of thinking. And when it comes to finite element code, you need to think about when things can happen. So can you look at the results before a calculation has been made? So it's non-linear. You need to think in that way when to prevent, for example, the user to show the results when there are no results. There are also some common properties on the user interface objects. So, for example, if you want to control if a user interface object is visible or not, you can use the set visible, and you can query using the isVisible method. So set visible, if you set false, it will be disappear. It will not be shown on the user interface. You can't interact with it either, so it's kind of completely hidden. You can also, if a control is active, so you can, if you set enable to true, you can click on it. If you set enabled to false, it will be visible, but you can't click on it. And sometimes that could be a good hint to the user that, for example, you can't show the results until you have done a calculation. When the calculation is done, you set enabled on the results button, for example. For certain controls, there is also something called a focus. And for example, if you have seen a dialog box with a lot of text entry boxes, only one of them can have a cursor in it. And the one that has the cursor has the focus. That you can control with using the set focus method. You can also say there are some attributes for a method for setting the fonts. If you have a control that, for example, a button has a text label, usually you control that using the set text method, and you can return the text using the text method. So these are found on most of the controls. So here's a bit more complicated example. I have 3 push buttons here, 1, 2, and 3. I have 2 methods that connect to these. So I have button 1 clicked, button 2 clicked. I connect them here to these 2 functions. And I just do it if I click the first button. So I just check if button 2 is visible. Then I set button 2 set visible false. So when I click the button, the first button once, it will hide the button. If it's invisible, it will show the button set visible. The second button here, if I click the second button, it will, if self button is enabled, it will disable that button. Otherwise, it will enable that button. So this is a very synthetic example of how that works. So you will get all these methods. You can actually run them yourself. So you see you have all the buttons here. So run this. I don't know why it's so small, but okay. So if I press the first button here, the second button will disappear. If I click again, it will appear. If I click the second button here, you can see that the third button is kind of disabled and I can't click it. And now I can click it. So this one hides the control, it's gone. And then if I press it again, it comes back again. This is disabled. It's visible, but you can't interact with it. Now you can interact with it. So you have these 3 states. This is how it should look like. My screen is not so strange. You can also have different styles on the windows. So this example here, we have init here with Qt window. It will show us the standard window. You can also have Qt window and Qt dialog, then it will be styled like a dialog window. And if you have Qt tool here, you can style it like a tool window. So this is a standard window. We have seen that before. And if we do dialog window, there is some look a bit different. You can see here that you have question mark here for help. there is only a close button here. There is no maximize button. You can also prevent this from resizing if you want, but by default, you have this as in a dialog style window. And finally, you can style it like a toolbox window, that is usually we have floating toolbars in an application. They're styled with a smaller caption bar here. So it's a bit smaller than before, a small close button as well. You can also control how the Windows is displayed when you start the application. So for example, you can do self-set Windows state, Windows maximize. And that's the same effect as clicking the maximize button on the window when you start. So if we run this application here, we have set window maximized here. Run. Still a window running here. Now you can see that the Windows is covering the entire screen. If you press the restore button, it will go back to the original size again. But, however, if you do the final one here, which is kind of a bit dangerous, you can do self window full screen. You need to know how to actually get out of this window again, because it will cover the entire screen with no controls. So then there is a Alt F4 you can press, which will. So now you see you have the entire screen. So for certain applications, for example, if you have a kiosk information thing, you can use this. And then, but you can see here, I can't even click anything here. But I can, of course, I can switch windows like this. But I can, using Alt F4, I can close the window. But that is half dangerous. But for if you develop a game, that is what you want. You want the game to take the entire screen. So the window full screen. Then we go into a topic called menus and toolbars. So if you look at many of the applications you're using daily, they have a menu and they usually also have a toolbar. And menus in Python or in Qt is implemented using the Q menu bar class. And to that class, you connect Q menus, and then you connect something called actions. An action is a special. So if you know how you have the menus and toolbars, many of the functions in the menus are duplicated in the toolbars. And to not have to implement several methods, one method for each toolbar event, for one action event, for the menu, you combine them into an action event. So instead of connecting the menu event to a method, you connect the method to an action, and then you connect the actions to the menus and toolbars. And the action also can contain icons and also keyboard shortcuts. So you store that in the action. So regardless if you place the action in the menu or in toolbar, it has the same shortcut, the same icon. And then you connect the events directly to the action instead of the controls themselves. So you can see here that I have a user interface here. And now when we have to use menus, we need to derive, instead of Q widget, from Q main window. Because the normal Q widget doesn't know how to handle menus. Q main window does. So the first thing we do is create actions here. So I have my action here. I attach the action to my own instance. I can set a shortcut here, Control T. And then there's a signal on the action called triggered. So if the action is triggered, you connect that to your own method here. So it's basically like connecting to clicked, but an action is triggered instead of clicked. And you can see then I create the file menu, menu bar, add menu, file. And then I add an action to my file menu here, my action. And then I have a method here to act what's going to happen when you actually call this action. So I will display a message box here with a message. Really small menus. So you can see here I have a menu bar here, and I have my action here. And you can also see that there is the shortcut is available on the right side, which is the convention in the user interface design both on Mac and Windows. And if I click this one, it will display a message. But I can also press Control T on my keyboard. It will also display this. So this way you can combine both having keyboard shortcuts and having menu items in the same, using the same, only single event and a single method connected. And of course, we want toolbars as well. So in this case here, I create a new toolbar and do self add toolbar. So this is the method that is in the main window class. So this is, it knows how to add a toolbar. And then to the toolbar, I add an action here, same action as before. And now you can see you have a toolbar here as well. So I have an action. I have a menu bar, same action I add to that menu bar. I have an add toolbar here with the same action. So I have only one place where I actually implement what is going to happen in both cases. So now I have a window here. I have my action here. I have an action here as well. Also the functionality of having to drag and drop the toolbar is already built in. You don't have to program anything to do this. This is kind of built into Qt. I'm not sure why they Control plus T. That should be in the shortcut should work here as well. Yes. So for a more complicated example here, just for illustration, I create several actions. So I have new, I have open in Swedish, of course, and I have spara, avsluta, klipp ut. And I add actions to all of these, and I can also set an icon here. So I can have an icon with the image file for this action. And that will be displayed both in the menu as well as in the toolbar. Okay, no images. There should have been images here. I don't know why. It's probably my resolution. But you can see here that I have menus here. And all of these corresponds to different actions. So click out, klistra in, open. I also hear shortcuts here for new, open, save, and quit. So this is a more complicated example. Here I have also a lot of more methods to connect. But you can see here I have a lot of menus. I have a lot of toolbars, but I still only have one method for each action. So actions can be connected both to the menu and to the toolbar at the same time. Another thing that is important when you design a user is to be able to lay out things in a window. What I have shown before now is the absolute position, that you place a button on a specific XY coordinate and specify actual fixed size. Now this is works for smaller examples, but what happens if you resize the window? Well, you have all your controls on the upper left side and a lot of white space. So you need to think about how to dynamically resize your user interface. And what Qt uses is something called sizers. These are special classes that are expert in organizing objects in vertical, horizontal, in grids in different ways, and will also resize the controls inside these sizers. So the first one, layout class, I will do something called Q, VBox layout. V stands for vertical. So this is a class that is an expert in sorting things vertically. So you can add things. You create your buttons here, and you create the layout. You add your buttons to this object, and it will automatically sort them vertically like this. It will make sure that there is a space between them. It will also make sure that it doesn't shrink the button too much. So there is a minimum size that it can't exceed. And it will also, if you resize it vertically, it will spread the controls out evenly. There it is. You see, if I resize now, the buttons will kind of move around. It also makes sure that you can't shrink it more than so that they fit inside a window. There's a maximum size, or minimum size of the button as well, so you can't shrink it too much. So expert in vertical size. Then, of course, we have the HBox layout, which is expert in sorting things horizontally. Same idea. You create a layout, you add your widgets to it. It will display sort your widgets horizontally instead of vertically. So see, I have 4 buttons now, and I can rearrange them like this. You will also see that I can't make them the window smaller than the minimum size of 4 buttons in row. You can also see that it puts some spacing in between the buttons as well to make it look so that they don't overlap. Then you can take the 2 concepts together. So every layout is also a user interface object that you can add to other sizers and layout controllers. So for example, if you want to achieve a user interface like this, have 4 buttons on vertically, have 4 buttons horizontally at the lower row, you can combine a vertical sizer. So I put 4 buttons like this and create a horizontal box layout, and I add my 5, 6, 7, 8 buttons, and then I add my layout to the horizontal box, the vertical box here. So VBox add layout HBox. The stretch here is a control that you can use. It acts like a spring. So if you put that spring in, it will try to maximize the size between. So in this case here, there will be a spring between button 4 and this lower row here. So if I resize, the spring will expand and push this row to the bottom. So you can see here, if I resize it vertically, you can see here, those buttons will stay on top because here is an invisible spring here that pushes down or pushes up these buttons here and pushes down the other ones like this. I can add this stretch anywhere. So I can do, for example, in the middle of those 4 buttons. So now you have 2 springs, one here and one here. This is also something that you can use to control your layout. Another layout that is quite efficient as well is the grid layout. In this case here, I can add buttons to a grid. So the grid is not coordinate based, it's rows and column based. So I can define myself here. I don't have to set the maximum or minimum. So 0, 0 is the first button. And I have button 9 here is a positioned row 2, column 2. Then we place the buttons like this. Then you can set how the different buttons will expand and change. So expanding here will allow the buttons to actually expand in size, both in vertical and horizontal ways. Here I can set margins here on the grid. So how much it should be top, left, bottom, and so on. I can also do stretching here on the columns, stretching on the rows. I would recommend if you get this example, try experiment with it and see how different properties affect the layout design. So my 9 buttons here, and if I do, you can see here that I had a stretch on this one here, and this will expand much more than these here around. But you can imagine here that you can also place, instead of buttons here, you can have other controls. You can have a text editor here in the middle. You can have buttons on the left side, right side here to create the user interface. So a good idea when working with users is actually use pen and paper to draw a user interface first, and then do the sketch, and then try to translate that into sizers, grids, and the different elements that you have to work with. I think we take a break here, 15 minutes. We're back here at 1:15. So the next part we will discuss how to convey messages and also use some of the standard dialogues that are built into Windows and also other operating systems. So the first part is message dialogues, small messages that you can show to the user to inform them something has happened. File dialogues, special dialog box for selecting save files, open files. Color dialogues to show colors, for example. So we will go through these 2 here. So you can display a dialog or message box using the Q message box module here. It has several different methods here. One is information. The first parameter here is which window it should be attached to. In this case, we just provide self because we are part of a main window, for example. And this is the title of the window here, and this is the message you send. Let's show them all at once here. So in this case, I have just an open dialog here, and I have a when I select the menu here, it will display a message here. You probably have seen this before. So if I do open dialog, you can see this is the standard message dialog. It shows the information here and the text you display, and then OK. And if you press OK, it disappears. Then you can do different levels here. So you can do critical. If we run this, then you get this kind of really horrible red cross here. And one thing to note when you do user interface designs, it's preferable not to use these kind of red warning symbols unless it's really critical. It's better to just show an information dialog, something happened, and then doing it like something really happened. It's not the good practice. It can also scare users to death. There is something in between, called a warning. Looks like this, and then you have a warning triangle. Should also be used with care. So if you can't use the information message, if it's something that's really critical or something really went wrong, you have to choose a warning. But critical is kind of really something got really bad. Then there is also an easy way of asking the user a question, for example. If you want to erase all the files of the user, perhaps you should ask him first. So then you can use something called a message bus with a question method. So here you can have the question here, and then you can provide different buttons you want to display. For example, yes, no, cancel. And the final one here is the default here. So if the user doesn't select anything, the default is no. And then you can check here. So it returns a result. So if the result is yes, then the user has pressed yes. Otherwise, the user has pressed no. Here we have this method here. Now you can see here that I have a vote or a race. If I press yes, it will say choose yes. And I press no. And if I cancel that, I do nothing here, it by default to no. Another thing that is very common in programs is asking the user for a file name. And there is a special module called Q5 dialog that you can have get open file name, get save file name. Same thing, the first parameter here is the window you want to that owns this dialog. Title, the default file name, and then this is a file name filter. So this parenthesis here will tell the user interface which files to show that you can open. So you only display files with *INP at the end here. And then return here will return the file name. It will also return something else that we're not interested in. So you put an underscore here just to ignore that. So if file name is not equal to empty, the user selected the file. So if the user cancels, the string will be empty. File open. Now you get, this is the standard Windows file dialog. So this is not something that Qt created. So Qt will call this, call Windows and ask Windows for a standard file dialog. If you do the same thing on a Mac, it will bring up the Mac standard dialog. So it will adapt to the platform you're running on. So let's see if I can select the file. Now you can see I don't have any input files here, so it's empty. I can do here, I can select star.star here. Then it will display all files. And if I select this one here, you can see here that the string return is the complete search path for that file. So all the directories to this file. And then that you can use later on to open a file in platform. So this is something you use in your user interface to open an input file, a JSON file, and you also will be possible to select which JSON file to save. Next, you can also ask the user for a new file name to save a document. It's very similar. Let's say file name instead. Same thing here. You can put the filter, and this will be the default extension to put on the file that you save. Then it will return you a suggested file name. This is how it looks on a Mac. And the return is the complete search path. So now we have to specify a file name. So I'll do a test here. And if I save here, you can see here that it returns you the complete file search path here. And also with this the test here, I just enter test. The dialog, the function automatically added IMP to it. So you can take that directly, store in your as an input file name, and use that when you open file in Python. So let's go through some of the controls available. Buttons we already covered. You can have on-off buttons. You can enable, disable. There's something called a checkbox, which has a state. It can either checked or unchecked. And you can use set check state to set the state. You can use check state to actually query if it's checked or not. Same thing with radio button. Radio button is a button that always occurs in a group, and only one of these buttons can be checked at the same time. Multiple checkboxes can have multiple checks regardless of the grouping. So let's look at the checkbox. So here you can see here that I have create them basically the same way as the button here, but instead you use checkbox, attach it yourself, and then you can have a set checked here. We'll put the check mark in the checkbox. There is a signal called state change that you can use that is triggered when the state of the check is changed. So I have a message box that shows the current status or the current state of the checkbox. So here I have my small checkbox here. Now you can see here that it calls out here. Check it again, it will display the contents. It's not necessary to have this state changed here. The checkbox itself stores its content, so you can query that later on in the program. For example, when you do a calculation, you can check if something should be done, and just use the isChecked method here to query the state of the box. This could be used to kind of trigger other events in your code. But if you just want to have an option for something, you don't have to connect the signal to it. Then we have the radio buttons. Those are a bit special because they are either checked or not checked, and only one of them in a group can be checked at the same time. So here you can see I have two radio buttons. I can connect them to clicked here. If I set one checked, the other one will be false. You see that you don't have to do Qt will automatically make sure that only one of them is checked at the same time. If you want multiple groups, you have to group them in groups. So basically put them in different layouts, or there is a group object to make sure that only one in a group can be selected. So you can have multiple groups with different selection status, but in one group, only one of them can be checked at the same time. Combo box is a multiple selection control text box. So you can provide a set of limited options. If you click on the selection box, it will drop down a menu to where you can select. It's a compact control, takes up little room, and the selection is the list that you're connected to on current item changed. Current item index returns the currently selected item. So on Mac, it looks something like this. On Windows, it's similar. So I create a combo box here. You add item to the combo box here by just adding strings like this, 1, 2, 3, and 4. You can set the current index here using set current index, so set number 3. And then you can connect the signal index change here to trigger when you select different items in this combo box. You see here in Windows, looks like this. I select here. So in this case here, I also in the event here, the signal here, I display first the index here, selected index, which comes from the event here, the method, and then the current text of the combo box here as well. So you can actually query for the selected text as well. It's called current text. Slider is a control for enabling fast input of numerical values. You can set a range from min, max, the steps on the scale. This is an example of sliders: vertical slider, horizontal slider. So you can set this should be vertical or horizontal. You can set the maximum value, minimum value, the current value, and so on. And you can also connect value changed signal to your own method here. That is called every time the slider changes. I know I have some minuscule windows. These are they're very small sliders. But you can see here that every time I change it, it will automatically call this method here. So you can, for example, have a slider for selecting the coarseness of the grid, small, large, for example. List box, similar to the combo box, but it displays a number of the items all the time. So you can select a box and have a list of items to select from. You can have a large number of options in this case. And if the items in the list box are too many for the box to display, it will automatically add scroll bars to the list box. So this is how it looks. So you have a list box of items here. You can have a scroll box here to scroll down the items if there are more than can be displayed. In this case here, I have a loop here that I just add 100 items to the list box. Same thing, you set current row changed, connect. So most of these controls are handled in the same way, very similar. So you can see here that I have 100 items from 0 to 99. If I select here, it's the item here that was selected. Now we come to the control that we will use a lot in this course, the line edit control. This is a control that enables the user to enter values, text, and so on into your user interface. It shows the text box where you enter values. You set the value from the beginning with set text, and then you can retrieve the values using text when at some point in the code when the user has entered text. Looks something like this. You can recognize it. Line edit control here. Set the text. Then I have a button here to, if I click the button, it will query the text box for the value here. So I will display the value of the text control. I can edit text here. And you can see you can query the value of the text box as well. So when you design your user interface, you will have a lot of line boxes where you have numbers, for example, and then you convert the strings to values. So that's input to your code. So they are always string. So they never contain floating point values. So if the user should enter floating point, you need to convert the string to a floating point. Also do some error handling on that, because how do you convert that to a floating point value? It's kind of coarse, you will get an error when you do that. So you need to handle that error to make the user interface easy to use. So in the next part, I will just discuss how you can combine your model with the user interface. So you have started to create your finite element model in the class, and now we will create a user interface to that class, and also the reasons why we divide it up in different ways. And the main reason we don't mix user interface code with simulation models is to be able to separate this and reuse the simulation code in different ways. It could be that you don't want to implement your user interface in Qt, you want to implement it in something else. Then you don't want to have to remove all the user interface codes from your simulation part. So if the simulation code doesn't know about the user interface, that's very good. However, the user interface needs to know about the simulation model. So the other way around is perfectly okay. So, but the thing you need to do is be able to update. When you start your code, you need to update your user interface with values from your model. And when you want to do the calculation, you need to retrieve the values from the user interface to the model. And you need to do that in a consistent way. I usually do that in two methods. I have one method called update controls that will take the values from the model and fill the controls. Other way around, update model. I have a method that will take the values from the user interface and update the model. And then we can reuse some of the things that we've already done. Reading model from disk. You can have file dialog to ask for a file name and then read using the method you've created. Yeah. So I'm going to just illustrate with a simple example here. I have a model object here with the text values, floating point values, options, and so on. And somehow I need to convert these things to create a user interface for this. I also have a string method that prints out the values here for my model. I have a user interface that looks something like this: text value, value, option, alternative, also value. And I have an execute method here to do some calculation or print out the values. So then I have update controls that takes the values from the model and update the controls. So in this case, I have my text edit controls here. I do set text, self model text value, value edit set text, and I convert using the str method here for string value here. So I go from an integer value to a floating point value to a string. I have set checked. I can do that because this is a Boolean. The set value here is an integer. I can set that directly here. And then I have to check here my model here if alternative 1, 2, 3, and I check the corresponding checkboxes here. Going the other way around, going from the controls to the model, self text value, I can just assign the text directly. When I go from string to the value here, I need to do a float here to convert the string to this one here. Option check here is checked. I can assign that directly. UI value, slider value, I can also assign that directly here. Then I have to query the different controls here to see which of them are checked, and I assign my model again the different values here. Then we can use these controls in different ways to, in our code, for example, if I start the program, I can do update controls. There's a single line. And also when I want to do execute, I can do update model to retrieve values before I execute. So I only have two places where I do this thing. I don't mix them around. I just do it in two places. So I will do a simple example here. I want to create a simple application for a simply supported beam. Very simple model here. I have a point load P, a beam with the values A and B. And some formulas here I want to implement and calculate the section forces, the moment diagrams, and so on, and the deflection. And the way I want to use it is I want to create a model here, beam simply supported. This is my beam model. I want to be able to set the parameters like this. I want to be able to loop over these here and just retrieve the values here using beam vx. And then have functions here that return these values automatically. So first, we create our class, beam simply supported. I create private variables here. So my member variables are private, A and B. L here is computed here from self A plus self B. I have self P, E, and I here. So I set sensible default values and everything. Then I will need some way to go from a string to a floating point value. So without errors here. So I have a special method called toFloat. This is the new value I want to assign. I keep the old value here as a safe block. So then I try here, convert float new value. If something is not, if you're not able to convert here, I will return the old value. So regardless of if I try to put some character alphanumeric things here, this will accept here with value error, and it will automatically return the previous value. So it's only a correct evaluation that will return a value. So this is a generic thing that you can use for most conversions. Then I create some get set methods here. So returning the A is no problem, so I can just return it. Then every time I try to set the value here, I call this self toFloat method. So then actually you can take any value here. It can be string, it can be Boolean, anything. It will only assign here if this conversion is correct. Get B, set B, and so on. Then I combine them to properties. So property A will get value from A, set A, get B, set B. L can't be assigned because you have, this is computed value. So it only has one get L. Then I have properties like this. And then I have, this I do just for convenience here. It's much easier to use A instead of self.A in the formula. So that when I do this, it's much easier to write the formulas like this. So then it will, if it's less than A, it will return this. If it's otherwise, it will return this formula. So then I want to do user interface. I want to do this table of deflections, section forces, and moment diagrams. And I can enter the values here and it should update immediately. Now I create my user interface class. I put it on a separate module. I call it beam window. I import my beam model like this beam model. The beam model is completely unaware of the user interface here. It's completely separate. I create a self beam object here in my init class on my window, initialize my GUI. I update my controls. I update my text edit. Now I create all my user interface objects like this. And I also connect, for each text box here, I connect self-editing finished. So when editing is finished, it will automatically call this method here. And here I have update controls. It will string self be made, just assign the text from this here. The text edit will be used to create the table output. So every time you change the value, it has to update the table. Then the other way around, I update the model, I assign BMA. And you can see here, I can use the text directly here, because the property with set A will automatically convert to a floating point. So here I go from model to controls, and here I go from controls to model. And when I do editing finish here, first I update model, so get the current values from controls, and then we fill the text box with section values, and then update controls again if there are invalid values that has to be removed. Let's see if I can. So here I have the simply supported beam class with all the methods here. I have my user interface here. And let's run this. I don't know. So if I change, for example, here 3 and go to the next one here, you can see it automatically updates here. If I do, it changes. You can see here, update mode, update controls. And if I should write, for example, here, I will do A here, press enter here, it will automatically convert back to 3. So we'll try the value at A. It remembers the old value. So if that is wrong, it returns that to 3.0 again. So this is why, and in this way, we have a user interface that is completely decoupled from the model. You can implement this as a web page or anything, but you can still reuse your Python code for the model. So now at the final part here, I will show you how to make this process much easier. So as in all the previous examples, I have manually created a user interface. However, that is, if you have a user interface, for example, take Word, it has 400 controls or something. You don't want to code that manually. So Qt comes with a tool called Qt Designer that you can use to lay out the controls. So it stores the user interface in a special XML file format called UI files. And then the UI files you can actually read by Qt to create the objects, the interface objects automatically. And they're all instantiated automatically for you instead of you implementing them yourself. So the way you do it is that you load your user interface file. There is a special module called UIC, User Interface Compiler. and you call load UI, and then you call your form UI here with the controls that you created from the Qt designer. This is where it will create the object. So if you put self here, all the objects from the user interface will be created directly in your main window object, just like you would have done manually. And then you can see the self push button here is actually the object that you created. The name you gave in Qt designer will be available here as well. And then you can use it like it would be created manually. So let's see here. I will try to create a simple form. So the Qt designer, if you have an Anaconda window, you should be able to just type the designer in the window like this. Looks something like this. On the left side here, you have all the user interface controls that you can create. These one are the sizes I mentioned before. These are the stretch items here, the springs. Here are the buttons, different buttons you can create. List view, group boxes, toolbars, line edit. Every user interface that was built into Qt is available. So let's create a new window here. We just do a widget here. Great. Then you have an empty canvas that you can kind of create things in it. So what I want to do is I want to create some buttons on the top. So I do like that. And then I want to create some buttons here on the left side. So I pull this out like this. You just drag them out and release them. You don't have to do it very precise. You can just do it a bit approximately from the beginning like this. And then I want to have some buttons here on the bottom here as well. And you can see here on the left side here, you have something called an object inspector, where you have the names of the buttons here. These are the names given by default. These will also be the names you will refer to them in the code. You can change the names here by selecting the object here and change the name. And I will recommend you to do that, at least for those objects that you want to interact with. You can create a lot of user interface things that you don't want to use just for decoration. You don't have to have them named in a certain way, but those buttons you want to use. And then I want to create text edit here in the middle, like this. So now I want to kind of group these buttons in a more public way. So I select these buttons here on the top. And now you perhaps don't see it here. There is some controls here for layout horizontally. Do like this. And these buttons here I want to lay out vertically. And these buttons here also vertically. These buttons here horizontally. So now I have five groups. So I have a control in the middle. I want them to be aligned on the top here. So the global array here, I want to have 3 rows. So 1 row with these, 1 row with this one, the text edit, and these ones here, and 1 row with this one here. So what I can do then is actually, I group the first one together here. This is a bit tricky to click here. I group them together horizontally, like this. So now I have, and then I select the main window here and say that the layout of the main window should be vertical, like this. So now I create the user interface with controls on left side, right side, and you could also resize this one here. You see here, it's completely dynamic. But what I don't like is these buttons here spread out like this. So then I will add a swing to it. So I do a vertical spacer here, and I place this here on the bottom. And it will expand like this. And then in my code, I had, let's see here, how this. I had a push button here, and I want, so I need to be able to respond to one of the buttons here. I need to rename one of the buttons here. So let's take the left button here. I call it push button. So I just put enter here, and you can see the name changes here. So now I have defined my user interface. I can save the file here. File, save as. You can see I've done this several times here. I do Form 8. I go into my code. So I now Form 8 here. I also changed the text of my button, my press me button. So that's wrong. I have to go back one. It should be press me button. Save again. And I changed the text here. So just to see that you can, the objects in the file will actually be present here in when I run the code. So let's see here. So now you see here, I created my user interface. You can see also that the top left button here changed the name here. So all these buttons have been created as objects in my code, and there you can respond to them and you can modify them just as you have created them manually. And if I press here, you can see button pressed here below. So you can respond. You can also see how nice it will rescale here. I have a text editor here, I can write text inside. So using the Qt designer will enable you to actually create much more powerful user interfaces. But I still recommend you to design your user interface on paper and then go into design, because it's true. Sometimes you can get stuck in design, you don't know what to do. So it's better to group them together. I want this to be left side in a group, this should be on top, and then you can have this logical rows and columns that you can resize. So I actually think that is it.